Hello there, this is Daniele from Toolchefs. Welcome to this new video. So today we're going to have a look at how you can use Python for interacting with your agents, how you can get information from a live simulation, but also how we structured our tools and Python code so that basically you can see our code and basically get to understand how we do things and how you can also do the same thing in your pipeline. As you might have already understood, this is a pretty technical video. Even if you don't know Python, you can still watch this video and see basically how Atom's code is structured and how easy it is to interact with live sim or even our tools and so on. So as you might know already, the menus in Maya and Houdini are pretty much the same. So we have the exporters and they're defined here. We have also tools, and both in Maya and Houdini they look pretty much the same. So we have the exporters and tools. So we have, for instance, the cache exporter, mesh exporter, the rig animation exporter, and so on. So let's have a look at the Python code. So this code here is actually what you have in your Atoms installation. So if you check in the scripts folder, you will find an Atoms Maya folder, an Atoms folder, and an Atoms Houdini folder. And as you can see here, but just having a look at it, this folder structure inside each one of those folders is pretty similar. So we have an exporters folder, a NodeBridge folders, a UI folders, and so on. And it's because if we check, for instance, the Atoms Maya, and also you see Houdini is pretty much the same. So we have an Alembic exporter, an FBX exporter. If we check, for instance, the FBX exporter for Maya, we see this file is pretty empty. We're just, instantiating a dialog that is defined inside Atoms. And then we're passing as an argument an host bridge, which is in this case is the Maya commands host bridge. A host bridge is basically is a class that defines how a dialog, or anyway, how some Python code that is from Atoms that is abstract should interact with the host application. So for instance, the FBX exporter dialog, if we go and check it just quickly, so that will be an exporter, FBX exporter. Basically, it will keep track of the host bridge that we pass as an argument to the constructor of that dialog, and then it will just call a specific function for exporting, in this case, an FBX. If you go and check in Atoms Houdini, the host bridge, if we check the commands host bridge, we see we have this export FBX method that just runs an hscript command for exporting the FBX. The same thing would be in the Maya commands host bridge. So you see here we're actually just calling a Maya command. The same thing happens for the Alembic exporter, for the rig and animation exporter. So whenever we export a rig and animation, also here you can find some information and you can access the tags that are on a skeleton, or you can get the selection from an agent group and so on. So feel free to browse this file and see all the functions that we have defined, so you really understand how we interact with the commands, how you can export things and so on. Some host bridges, like for instance this one, the Maya and also Houdini commands host bridge, they're just full of static methods, so you don't really need to instantiate them. You can just call straight the class and then just do Maya commands host bridge dot, and then again call the export FBX or export Alembic or any other of these methods. We've done this because so you don't have to instantiate the object, and if you have to run multiple calls of these methods, then you don't incur in any slowdown and so on. So then also, so just to explain the host bridges, so we have the commands host bridge, which is again just for running commands, like for instance for exporting files and so on. We have the points layout one, which is the one that is used by the layout tool. We're not gonna check it, but maybe you can check see the code, and if you have any question about anything that I'm saying, just feel free to ask them on our Google group. Then we have the variation builder, which is the host bridge that is used by the variation builder for exporting variations or even building variations in your host applications. The Atoms node is the host bridge that is used for interacting with the Atoms node inside your scene. And then we have the Atoms group host bridge, which is the host bridge that is used for interacting with an agent group. So for instance, with this host bridge, you can add modules, delete modules, get the values of metadata on a module, connect, set keyframes, and so on. So for instance, let's go in Maya just a second, and let's just try to run some code here. So for instance, we have as you can see here, we have created, we have imported 2 modules, so the Atoms core and also these Atoms group, and importing this class, so the Maya Atoms group host bridge. This class you have to instantiate if you want to use it, and also you have to pass the object, an object. In case in Maya you have to pass the name of the shape of the agent group node. In Houdini you have to pass the full path of the node, but we're gonna check Houdini in a second. So here, for instance, we can run that code, and then from here we can say get all modules, and this will return a list containing some tuples that contain basically the name of the module and also the type. You can also do get module type by name, I think is sorry, got your module name by type. Let's see if that is there, and then we check agent separation, because I think we have an agent separation in this scene. Yeah, so this one will return you the first module which is of this type. Then if you want to know, for instance, the value of a metadata, you can do get metadata value. You will have to pass the module name, then the name of the metadata. So in this case it's weight, is that one, and then we have to pass the type in this case, so double metadata static type ID, like that. And you see here we have got just that value. You can also, for instance, check the distance and so on. Again here, because this host bridge has basically this agent group as app object, then everything that anytime you call something on this object, you're just querying data from this agent group. So if you want to just query data from another agent group, just set the object, set pass the shape of the other agent group, and then you'll be able to then query the metadatas, or even set metadatas and so on the other agent group. So if you check let's go in Atoms Houdini, and we can see Atoms group, you can see get override value, so you can get all the overrides, you can get so this would be for getting multiple overrides values. So here you can just get one, and you have a bunch of functions here and methods that you can check to see just how we get stuff and set stuff on an agent group. So this is how basically you interact pretty much with with the agent groups and commands and so on. The tools also works in the same way. So for instance, if we go in the UI and then we go in the tools, we have the agent deleter, for instance, that is the same thing. So we pass some host bridges to this dialog that is defined inside Atoms, and then that dialog then will use these host bridges for running some commands, setting stuff on the agent group and so on. So yeah, this is again how the folder structure is set up. There is of course more to more in these folders if you want to have a look. If you have such feedback about this video and want to know more about this folder structure, and if you have any specific question, just feel free again to ask on the Google group, or send us an email on at support@toolchefs.com, and then we'll try to make a video just to explain the things that I'm missing in this video. Okay, so the other thing that you can do, for instance, in Houdini or in Maya, we can also query live data from the simulation. So for instance, let's see here, we're just querying so here we can get the agent group that is attached to that agent group here in our Houdini scene. So when I say we can access the agent group, it means that we can access the internal Atoms agent group. So for instance, if we do that and then we do print G, so you see here we just got an Atoms agent group. If we have an agent group, then you can iterate through all the agents. So for instance, for agent in agents, this method will return you a list of all the agents belonging to that agent group, and then we can say print agent type. So we can access the agent type from here, and then we can say name just for printing the name Here we have just a bunch of men, so that's all we get as a return. But you can also query, for instance, if you want to know how many joins has the skeleton of this agent, you can say skeleton .num joins that, and you see the men, all the men have 17 joins. So you know, you can get all the information regarding an agent type, and then you can also get the metadata of an agent. And you know, this stuff is great just to, you know, query quickly what's in your scene, and to see quickly if all the settings that you have applied on your agent group are actually being sent to Atoms. And now, especially if you start writing, you know, custom Python code, and you know, just to debug quickly things. So for instance, if we say we have the metadata, we can say print metadata group ID, and then that should be uppercase and then value. So here we are printing all the group IDs. We can also print the variation if you want, but I don't have any variation signed here. So let's say just query the frame rate, for instance. So in this way, basically, you can query all the metadatas that are you know, listed on our documentation, and it's pretty useful. So you wouldn't be able to set any stuff from here. This is just, you know, for accessing data and, you know, reading data. If you want to actually set some metadata, or maybe, you know, changing the pose of an agent, for that kind of purpose, you would have to write a behavior module in Python. One thing that is useful to know is that whenever you, for instance, let's print the group IDs. So we just said that the agents method returns you a list of agents for belonging to the agent group, but sometimes, you know, maybe you have deleted an agent, or it could be that the agent group that doesn't really it can be that the group ID doesn't really match the index of that agent in this list. So if you have the group ID of an agent, the best thing to do in order to access that agent is just to call the agent method, and that and pass in the group ID, and this will actually return you the agent with that group ID. So if we do this, here we have the agent, and we can do again metadata group ID and then dot value, and it should return you 0. So this is basically safe to do whenever you have a group ID and you want to access an agent. Just always use the agent method on the agent group. Another way to get the internal agent group is also to use directly AtomsUDINI. So if you can do AtomsUDINI get agent group like this, and then you actually pass the same thing that we passed here to the host bridge. So you see, and in Maya is the same. So the only difference is that in Houdini, wherever you have in Houdini is AtomsUDINI, while in Maya is all with Maya. So let's just go back to Maya. If we do Atoms Maya, of course you have to change the name because they're not the same, but you see it's basically the same thing. So once again, just to stress out this fact, like the Python folder, the workflow between applications, how you can access data, how you can create behavior modules is always the same. So if you see a video that has been done for Maya, but you are a Houdini users, or maybe you are a Maya user, instead you just see a video that's been done in Houdini, if that feature is also present in your host application, you can check that video, and because the workflow and the Python code is pretty much the same, you can get your head around how you can do the same thing in your host application. So yeah, this is how you can access the live sim data. And also let's just do quickly the last thing. So I'll show you actually how can also access the pose. So we can do pose like that. So now we have the pose of the agent, and then you can do print pose, joint pose 0. So you're getting the joint pose of the root in this case, because the first joint of the pose, and then you can do translation, for instance. This will return you the translation of the root of the first agent. So okay, so I think this is all for this video. Once again, feel free to browse the Python code that is within your Atoms installation. And if you have any questions, just feel free to send us an email or ask question on our Google group. Thanks for watching. Bye bye.